Now look at the part 2 of equilibrium chapter. So this is equilibrium part 2, right? So this is the question number 9. The value of delta H. So ninth question, when x2 react with 4 times of y2, it produce 2xy4, right, is less than 0. So its delta H is given less than 0, right? So the formation of, so it is talking about formation of xy4, right, will be favored at. It is talking about favorable condition of chapter 9. So when less than 0, the given reaction is exothermic. So write the points for important. So delta H less than 0, the reaction is exothermic. Reaction is exothermic, right? According to Le-Chatelier principle, write the second point. According to Le-Chatelier principle. Le-Chatelier principle. Principle for exothermic reaction, forward reaction is favored, right? So for exothermic reaction, forward reaction is favored. Forward reaction is favored, right? So when temperature becomes low, so next condition will be temperature is low, right? So forward is favored when pressure of the reaction become high. So when forward reaction is there, pressure is high. Pressure is high. So the reason is that high pressure reaction tends more in direction where there is less number of gaseous molecules. So you can count the less number of molecules, right? So in the product side, number of mole is 2, but on the reactant side, number of mole is 5, right? So that's why it is moving towards the forward direction. It is talking about forward direction. Please write this one. Now look at the question number 10. So see. So for the reaction like nitrogen plus oxygen produce 2NO, right? The equilibrium constant is K1. So K1 is nothing but it is your equilibrium constant, right? So equilibrium constant for the reaction it is given. So when 2NO plus O2 produce 2NO2, so equilibrium constant is K2 for this reaction it is given, right? So what is K for the reaction? So NO2 is dissociating, producing half of N2 plus O2. So this is K for this reaction. So see how they are related to each other. So you have to find it. So for the first reaction, it is how it is related. So it is K1 is equal to concentration of NO raised to 2 divided by N2, concentration of O2 raised to 1. Now for the second equation, it is K2 equal to concentration of NO2 raised to 2 divided by NO raised to 2 divided by O2 raised to 1, right? So for right K, it is given K for this reaction. So it will be half of the concentration of N2 raised to half O2 raised to 1 divided by concentration of NO2 raised to 1, right? So this is in the upper part. Which one? This is, right, on numerator. So what I will do? So I will divide K2 by K1. So what we get? K2 by K1 dividing, right? So this will be NO 2 raised to 2 divided by NO raised to 2 divided by O2 raised to 1 divided by NO raised to 2 divided by N2 raised N2 concentration O2, right? And now cancel the part which is getting cancelled. So this is why cancel with this one, right? Or it is getting cancelled or not? So multiply this and upper with this lower part. This O2 will be get cancelled. N2 is there. So remaining will be what? It will be NO2. NO2 raised to 2 raised to N2 O2 divided by this will become, this will be multiplied. So NO2 NO raised to 4. This will be multiplied now. And next is O2 raised to 1. NO, this will be Na raised to 4. This and this multiply O2 raised to 1, right? So this and this will get cancelled. So write the remaining part. So it will be K2 by K1 is equal to NO2 raised to 2. See the previous slide. So into N2 is there also, right? It will be N2. Next is NO raised to 4. O2. O2 gone now. So 1 is remaining here. Now see this one. So how they are related? This is K. So write here K part also here. K is equal to how much? It is N2 raised to half. N2 raised to half. O2 raised to 1 divided by NO2. 2 raised to 1. So how they are related, you have to just observe. So you can see when we multiply this equation or a squaring this by 2, squaring both sides, squaring both sides, then it will become KSH square equal to concentration of N2 O2 raised to 2, right, divided by NO2 raised to 2, squaring both sides. Now see the observation now. NO2 N2O2, NO2 N2 or NO4 is there, right? So wait a second. Let's see the next solution of that reaction also. So see. So how it is given? So 10th one. Look at the next explanation of question number 10. So it is N2 plus O2 produce 2NO. So equilibrium constant is given, that is K1. And for K2 it is given 2NO
Sir, screen पर दिख रही है.
O2. So first reaction when N2 react with O2 it produce 2NO, right? And for the second one it is 2NO plus O2 produce 2NO2. So for this reaction equilibrium constant is given K2, right? So when we are taking a square root of the first one, then we are getting this equation as after taking a square root, taking a square root. So it will be half of N2 plus half of O2 produce 2 by 2 NO. So equilibrium constant will be the square root, right? So now see for the second one, take the square root of the second one also. So this will become 2 by 2 NO plus half of O2 produce 2 by 2 NO2. This will become square root of K2, right? So now add this Don't laugh. So 2 by 2 is 1. And this will become 1. This will also become 1. Now add. Adding the equation, what we get? So it will be half of N2 remaining, right? And this one NO will remove this one. And this half O2 plus half O2 will become 1 O2. Right? And 1 NO2 will be remaining. So it will be K. Right? So this will become K1 into K2 raised to half. So what we have to do? We have to find the K relation with the 10th one. So 10th equation is given, that is NO2 dissociate to half of N2 plus O2, right? So this is K given. So you can just relate it. So this is in the reactant part. This is your reactant part and this is your product part. So for this K is nothing but it is half of N2, right? So you can just observe this product, it is here in the reactant form. So K, what will be the K? K will be the reciprocal of 1 upon K1 into K2 raised to half. So this will be the easy way to find the answer. Now look at the question number 11. In which of the following equilibrium Kc and Kp are not equal? So it is talking about Kc and Kp. This is equilibrium constant at concentration C. This is your equilibrium constant at concentration C, and this is equilibrium constant at pressure P. So please control yourself. So C, the 11th. So for finding the relation between Kp and Kc, there is the formula Kp equal to Kc RT raised to delta N. So change in mole should be equal to how much? It should be equal, right? So when it will become equal? When delta N is equal to 0. So delta N is nothing but change in mole. Change in moles. So Kp is equal to Kc RT raised to 0. Then it will become Kc. Then formula will be equal to Kp, right? So now see the first equation. It is given 2NO producing N2 plus O2, right? So change in mole is product mole. How much moles are there? 1 plus 1. So it is 2 minus 2. It is equal to 0. So for this reaction, Kp equal to Kc, right? So you have to find for which it is not equal. So it for first equation it is equal. Now for the second one it is SO2 plus NO2 producing SO3 plus NO. So now see the change in moles. It is 1 1 1 1. So it is 2 minus 2, that is equal to 0, right? So Kp will become Kc now. So for the third one, see, for third one it is SO2 plus I2 producing 2Hi, right? So change in moles is 0. 2 minus 2, 0, right? Now for the last one, C plus O2 producing 2CO2. So change in moles is nothing but it is minus 1. So here Kp is not equal to Kc. So answer will be the fourth one. We have to find which one is not equal. So last one is not equal to Kc. Now look at the question number 12. If the concentration OH minus in the reaction, so it is FeOH3 producing Fe3 plus 3OH minus. Right. If the concentration of OH minus in the reaction is decreased, if concentration of OH minus in reaction is decreased, right, by 1 upon 4 times, then the equilibrium should be. So it is talking about Fe3 plus how much it is increased. So now look at the question number 12. So first I have dissociated the reaction, right, in the form of the product. Now first write the equilibrium constant for this reaction. So it will be Fe3 plus concentration into OH minus raised to 3 divided by FeOH3 concentration, right? Now equilibrium constant remain same at the temperature. So write this point. So K equilibrium is same at constant temperature, at constant temperature. So let's increase in the concentration Bx. We are observing it. So this concentration will be Kc is equal to X of Fe3 plus. So it is talked about the increase in concentration into concentration of OH minus. So it is reduced to 1/4. So I will write the value of 1/4 here. It is, you can see clearly it is given. So it will be 1 upon 4 of OH minus concentration raised to Q divided by, right. So it will be FeOH raised to 3. So Kc will be equal to how much? Right. So see here, this is your new concentration after increasing also remaining equilibrium constant same. So this is your first equation, this is your second one. So this will become now X into Fe3 plus, right, 1 upon 4 raised to 3. How much it is? It is 64, right, into OH minus raised to 3. So see, I will circle it with this green color. So this part is same as from the equation 1, right hand side, this part. So it is equal to X upon 64 times of Kc, right? So this will be the relation. So what we are getting, this Kc and Kc will get cancelled. So X we are getting as 64 times, right? So when we decrease the concentration of Fe3 plus, right, concentration of OH minus, OH minus we have decreased, right, 1 upon 4 times. So Fe3 will increase 64 times. So how will you solve? After writing the equation 1 and 2, you can relate the Kc value and we can get the X value. So please write it down. Very important question. Now look at the next sum, question number 13. HI dissociate to form half moles of H2 plus half moles of O2. Right. So equilibrium constant for this reaction is given, that is 8. So equilibrium constant you have to find for this one. H2 plus I2 produce 2 moles of HI. Very simple question. So this is the reverse of this one, na, first equation. So for this, suppose Kc1 we are finding, so it is HI concentration is to 2 divided by concentration of H2, concentration of I2. Right. So this is the reverse of that. So it will be 1 upon 8 raised to 2 times. So this is the multiplication of 1. This is the multiplication with 2. So answer upon this will be answer. Answer is 1 upon 64. It is asked in 2008 AIPMT.